There is something deeply wrong with how we build homes today. In the coldest places on Earth, people once lived comfortably in houses made of dirt, grass, and stone, while modern homes filled with technology fail within hours when power is lost. In the mid-1980s, researchers studying a traditional Icelandic peat house during winter recorded indoor temperatures holding around 58 degrees Fahrenheit while the outside air dropped to -40. There was no furnace, no electricity, no central heating system. Just thick walls built from stacked turf and stone, and a small fire that burned only a few hours a day. Even after the fire went out, the house stayed warm for more than 3 days. Families lived in these homes for generations, surviving Arctic winters that would make a modern house unlivable in a single night. Now compare that to today. When the power goes out during a winter storm, even the most expensive code-compliant house can drop below freezing in less than 6 hours. Pipes burst, families huddle under blankets, and by morning the house can no longer be lived in. The question is obvious. How did people survive extreme cold in buildings made from earth and grass, while modern homes packed with insulation and advanced heating systems turn into traps the moment the grid fails? In 2007, researchers at the University of Iceland ran a revealing experiment. They built 2 structures, each about 400 square feet. One was a reconstructed peat house built using traditional methods, with walls 3 to 4 feet thick made from turf blocks cut from local bogs and tiny windows barely a foot tall. There was no fiberglass, no vapor barrier, no modern insulation. The second building was a modern home constructed to current standards, with high R-value insulation, vapor barriers, and energy-efficient windows. On paper, the modern house looked far superior. Both buildings were placed side by side in the same location. The outside temperature was -15 degrees. Both interiors were heated to 68 degrees, and then all heat was shut off. The results shocked modern engineers. The modern house dropped to freezing in 9 hours. The peat house, after 48 hours, was still at 56 degrees inside. After 4 full days without heat, it remained well above freezing. The modern house became dangerous. The peat house remained survivable. Engineers often point to insulation ratings and say this should be impossible. A peat wall has an R value around 8 or 10, while the modern wall may reach 30. But R value only measures heat flow under steady conditions. It ignores thermal mass entirely, and thermal mass changes everything. A peat wall 3 feet thick weighs more than 60 pounds per square foot and can store enormous amounts of heat. Peat holds more heat per pound than concrete. When you heat a peat house, you are not just warming the air. You are charging a massive thermal battery. Heat from the fire sinks deep into the dense walls and is stored there. Once warmed, those walls slowly release heat back into the living space for days. Studies in the Faroe Islands showed that peat walls remained warm to the touch more than 70 hours after the last fire, keeping indoor temperatures 30 to 40 degrees warmer than the outside air. Modern walls are light. Drywall, plastic, fiberglass, and thin siding form a hollow sandwich weighing only a few pounds per square foot. There is nothing to store heat. Insulation slows heat loss but holds no energy. When the furnace stops, warmth escapes quickly through leaks and windows, and there is no reserve to protect the occupants. Traditional builders understood this deeply. Peat blocks were cut from bogs where the material had been compressed for centuries, forming dense, stone-like blocks that stored heat exceptionally well. The blocks were cut in spring, dried through summer, and laid into walls in autumn. Each block was carefully fitted. The walls were solid mass from inside to outside. Their thickness was not just insulation, it was storage. It could take more than a full day for outside cold to push through a 3-foot peat wall. By that time, the fire would be rebuilt. The house behaved like a battery, keeping temperatures stable for days. The walls were only part of the system. The roofs mattered just as much. In modern homes, roofs are thin layers of shingles, plywood, and a little insulation, weighing only a few pounds per square foot. Heat rises and escapes fastest through the roof, and there is almost no mass to stop it. Peat houses had living roofs built from thick layers of sod and grass, sometimes 2 feet deep, laid over bark or wooden planks. A single square foot of sod roof could weigh 50 pounds or more. That mass sat directly where heat wanted to escape. When the fire warmed the house, heat rose into the sod roof, where soil and grass absorbed it and slowly radiated it back down into the living space for hours after the fire died. It was like placing a heated blanket over the entire house. The living roof also sealed itself. Grass roots formed a continuous flexible mat that closed gaps, blocked wind and rain, and moved with the structure over time. Modern roofs have thousands of potential leak points. Sod roofs sealed themselves naturally while still allowing moisture vapor to escape. In summer, growing grass kept the house cool. In winter, the dense root and soil mass held heat like a thick quilt. Research on traditional Icelandic turf houses showed that sod roofs contributed up to 30% of total thermal mass. Houses with intact sod roofs stayed warm far longer than those retrofitted with modern materials. Combined with massive walls, the roof created a complete thermal envelope that held heat from every direction. Windows were another critical difference. Modern homes are filled with glass. Floor-to-ceiling windows, sliding doors, walls of glass designed for views and light. Even the best triple-pane window has a far lower insulation value than a wall. Every square foot of glass loses heat several times faster than insulated wall space. In modern houses, windows account for a huge portion of heat loss despite covering a relatively small area. Peat houses had tiny windows, sometimes none at all. Light came through small openings or smoke holes. This was not just about cost. Builders knew openings leaked heat. Windows were set deep into thick walls, creating tunnels that blocked wind. At night, openings were sealed with wooden shutters or treated skins. Archaeological studies of medieval peat houses show window openings made up less than 2% of wall area, compared to up to a quarter in modern homes. Airtightness was achieved differently as well. Modern construction relies on plastic barriers, sealants, and wraps that fail over time. Every outlet, pipe, and fixture becomes a leak. Testing shows many modern homes leak as much air as an open window left wide open. Peat houses achieved airtightness through mass and simplicity. Thick walls had few penetrations. Peat blocks compressed together and sealed naturally. Any gaps were packed with moss or more peat. The heavy sod roof pressed down on the walls over time, tightening everything further. Tests on historic peat houses have shown air leakage levels better than many modern high-performance buildings. Moisture was handled intelligently too. Modern walls trap moisture when systems fail, leading to mold and rot. Peat walls breathe. They absorb moisture when humidity is high and release it when conditions are dry. Water can enter and exit without damage. Studies show indoor humidity in peat houses stayed within ideal comfort ranges year-round without mechanical systems. Heating methods follow the same logic. Modern forced air systems heat air, which holds little energy and disappears the moment the system stops. Peat houses used radiant heat from a central hearth. Fires heated stone, walls, and floors directly. Those surfaces radiated warmth long after the flames were gone. Radiant heat feels comfortable at lower air temperatures. Warm walls at 60 degrees feel better than cold walls at 70. This building tradition was abandoned not because it failed, but because it did not fit industrial speed, cost models, and cheap energy. After World War II, construction shifted to factory materials and rapid assembly. Peat building required local knowledge and time. It could not be mass-produced. Cheap energy made inefficiency acceptable. Big windows sold houses. Survival was replaced by appearance. The lessons remain. Thermal mass, airtight simplicity, small smart openings, radiant heat, and resilience without constant power. The people who built these homes were not primitive. They were practicing physics refined over centuries. That science still works. We simply forgot how to use it.